Thank you for tuning into Mathematical Modeling, a project by Allison Jarrell. The things you're going to need for your problem today are going to be a pen, a graphing calculator, and a basic understanding of how to derive the area of a triangle and the Pythagorean theorem. So the first thing we need to know is our problem. A rectangle is inscribed in a semicircle with a radius of 12 inches. Write a function to model the area of the rectangle in terms of its height h. What is the maximum area possible for the rectangle? Between what values for the height will the area be greater than 100? So the first thing I did was I drew my semicircle. I personally am someone who needs drawings to help guide me, and so I drew half of a circle and then I wrote that the radius was 12 inches. And so next, I added my x and y axis into this drawing and also included the inscribed rectangle. And I noted that this right here is the height, while this point here is going to be xy. So another thing you need to notice in this drawing is that this radius here has made it so that this right here is a right triangle. A right triangle is a triangle where one angle is equivalent to 90 degrees. When you get a right triangle, you're able to use something called the Pythagorean theorem. So what is the Pythagorean theorem? What this is a formula for right triangles that help decide what this last base is going to be. So the Pythagorean theorem is pretty much x squared, our x being unknown, y squared, which is our height, and r squared, which we know is 12. So we know that 12 squared is 144, and h squared is going to go in place of y. So then what we're going to end up with is that this last base is going to be equal to the square root of 144 minus h squared. And so then what we're going to get next is that the height is equal to the square root of 144 minus x squared. But then we also have to realize that that x we just got is only accounting for one of these. And so what we need to do is we have to write down that the area is equivalent to 2x times the value of height. And that right there is your answer to number 1. So for the next of the problem, all you're going to need is your graphing calculator. And so the first thing you're going to do is you're going to hit your y equals button and type in your equation. 2x square root of 144 minus x squared. And then you're going to hit graph. And this shows us the function of the area when it is being compared to height. And so what we're going to need to do for question 2, which is asking the maximum, the height where the area is at its maximum. And to do that, we need to do second calc and go down to number 4 and hit enter where it says maximum. We're going to move our left bound there. Move our right bound there and hit enter again. And there it's telling us that our maximum is 8.48. That's our maximum height when the area is at 144. And that right there is your answer to number 2. Next, number 3 is asking between what values for the height will the area be greater than 100. And so that means that you need to go to your y equals and put out a line at y equals 100. And then you're going to hit graph. And so right there we've seen a line. And so we need to get the values above this line. So what we're going to do is we're going to go to second, calc, intersect. And so the first intersection is going to be at 4.49. And then the next intersection we move it over here. Okay, well now this isn't working. Second, calc, intersect. And then it's going to come out that your next intersection at y equals 100 is going to be 11.1268, and that's your answer to number 3. And so to quickly recap, your answer to number 1, a function of the area of the rectangle in terms of its height h, is that the height equals 2h square root 144 minus h squared is going to give you the area. And then 8.48 inches is going to be the maximum amount for the area, where the area is going to equal 144. And then number 3, between what values for the height will the area be greater than 100? And that is between 4.49 and 11.13 inches as the height. Thank you.